Hello, welcome back. So, in the previous session, we have just performed a basic preliminary step of text cleaning, that is, dropping off empty rows, right? So, null values present in the data frame. So, finally, we have ended up with a data frame which had which have 70,941 rows and 23 columns. So, the original dataset, if you can see, the original dataset was where is it? Yeah. So the original dataset was 71,044 rows and 25 columns. But after dropping the non-significant rows and columns or insignificant rows and columns, we are left with 70,941 rows and 23 columns. Okay. So this is sufficient enough to perform other text processing activities or other step text process pre-processing methods or the techniques to go ahead with. So before I am going to perform all the important text pre-processing step, that is lower casing, removing punctuation, removing stop words, lemmatization, spelling correction, normalization and standardization, and finally noise removal. So these are all the steps we are going to follow or going to implement on our data frame going forward. So before that, one thing I have noticed in the column names, that is, you can just see that review text and review title. So these two actually seems to be better together. So this review title will actually explain in short about what this review text is going to be, right? So you had also seen that on a particular Amazon website, right? So as I shown, the particular title say, okay, I am very much satisfied with the product purchase. So that will be the title, and there will be a review below that. So these two seems to be better together. So that's why what I am going to do, I am going to combine those two columns into one. Okay, so that column is going to be review. Okay, so I am joining these two columns into one column called as review. So df review equals to df of review title dot map of str. This is very much important. I am going to map each and every title with the particular review text. So map of str plus space. So I am going to add a space between the review title and review text. So that's why I'm going to use this concatenation of space between them. So now I am ready with the TF review column. Okay. Now it's time to perform lower casing. As I mentioned, it's very much or very preliminary step to convert all the characters in the given text corpus into lowercase to make the total text into case insensitive. So for that, what I'm going to do, I am going to take the column df review equals to df review dot apply lambda function. So this is very much important. So this lambda function, what it will do internally, performs a for loop with a sophisticated manner. So lambda x is to x. So it will take each and every value. X is one particular value. For a given instant of time, x is some value, and it will take that x value and convert it into lowercase and give that back to the list here, or the original data set, so, or the original column. So it will take each and every value. The x represented here will be the each and every value present in the df review column. It is going to convert each and every value into lowercase. So let's just have a look at very first row. You could clearly see that all the characters, all the words in this particular row is converted into lowercase. Our first step is done. Then you could clearly see that we have punctuations, comma, double full stops, exclamatory marks over here, etc. So these are very much unimportant when it comes to text processing. So we'll just remove those punctuation. So apply the similar lambda function, but instead of lambda function, we are going to use a replace method present for the string. So what I'm going to do over here is I'm taking that particular column dot str dot replace. So this is one of the regular expression which I'm going to use over here. So what does this square bracket starts with reverse slash w and reverse slash s represent? It is basically a set of punctuations, right? So it's going to replace the punctuations with nothing, not even a space, with nothing. Suppose if there is a full stop, it just removes that full stop. Suppose if there is a exclamatory mark, it just replaces the exclamatory mark with nothing. So if I do that and have a look at it, you could clearly see that there are no punctuations left in the data set. So the very good full stop is removed, then hype exclamatory mark is removed, gym exclamatory mark is removed, etc. So all the punctuations are removed right now. Now the next step would be to remove the stop words. So what are stop words? As I defined earlier as well, these are the connecting words to make the or to build the particular sentence, but they don't bring up the contextual meaning or contextual sense for the entire sentence. So you can just drop off those punctuations or stop words present in the given text. So what I'm going to do, I'm going to import the stop words. I have defined this here. Stop equals to stop words dot words of English. So I have used the NLTK imported stop words over here. You can use that the spacey model as well. So df review equals to review dot apply. I'm going to apply a lambda function again. What does this do over here? You could see from here. So it's a list comprehension again. So if word is not in stop, so this stop contains all the stop words, right? So if the word is not in stop, I'm excluding that, right? If word, if that is not present in this particular dictionary or set of large list, I'm going to split each and every word and I'm going to add this condition. So for each and every word in x dot split, if that word is not present in the stop words, then append it to the particular list. So this is the list I have defined. So clearly this list will consist of all the words excluding the stop words. After doing that, just have a look at it. You could clearly see that the above sentence is clearly cut shorted into simple form. So it has just so removed so, I, her, just, this, etc. and just left with more important words or more categorical terms basically, which have the meaning or which have the impact on the sentence or a sentiment of a sentence. Then we will perform another step, that is lemmatization. We can also do stemming as well, but as I mentioned when explaining about lemmatization, that when we have a most sophisticated, well-versed task to perform in the NLP, we have to approach lemmatization. So lemmatization will actually convert the word into root form, and that root word form also have a meaning or a make a sense basically. So I'm also considering POS tags. So adding POS tag along with the lemmatization known to be yield better results than performing the lemmatization individually or alone. So for that, what I am going to do, if the POS tag in the given word net, in the word net, I am going to check whether it is starting with J, that is adjective, verb, noun, and R, that is adverb. So if that is the case, I have defined a function over here. So while I have also defined a function to lematize the sentence. So this is the function I'm going to use this. So why I'm going to define in a function? Because I can reuse it again and again, right? So that's why I define lematize the sentence. I'm going to pass a sentence for this. For each and every tagged word, it has taken each and every word, and based on each and every word tag, it is going to lematize. You could just see lemmatized sentence equals to append dot word. So it will take the word and the particular keyword tag associated with it, and then it will lemmatize that over here and add it to this particular list, that is lemmatized sentences. So lemmatized sentences consist of all the words along with the POS tag, and it is already based on the POS tag. So suppose if there is a POS tag, say verb or a adjective, and that word is already in the right word or right form, then it will not do a lemmatization. It will just append it to the lemmatized sentence. Otherwise, if that doesn't contain any of these four tags, then it will try to lemmatize that word. So I will define this function. Now I am going to apply this on the review column. Let's have a look about what does it has yielded. Okay, so this was the sentence which we had after removing the stop words. Here you could see there is a word called metaphors. The root word for this metaphors would be metaphor, right? Yes, clearly you could see that it has converted it to root word or lemmatized into root form, but without losing the actual meaning, also the actual grammatical nonsense of that particular word, right? So by using this wordnet or the POS tag approach, we have just defined to have a better results on applying the lemmatization. So now we have done the lemmatization. We are left with two more steps, that is spelling correction. Yeah, so as I mentioned, spelling correction is very much important because there are customer reviews where the reviews will be consisting of the words with a lot of spelling mistakes. So we have to eliminate or correct those things. So I have defined the spelling corrector or spell checker here. Then I'm going to apply the lambda function for each and every word in the NLTK.word tokenize. So there these are the sentences, right? So I can't correct each and the entire sentence in a single go. So what I need to do, I have to tokenize each and every word, or I have to take each and every word and I have to correct the word for that basically. So for that, what I'm going to do, NLTK.word tokenize will actually split the sentence into individual word. For each and every word in that particular tokenized list, I am going to apply this spell corrector. So what this spell corrector will do, it will have a dictionary inside already. In the back end, it will compare the particular word with the dictionary, whether there is this particular word present in the dictionary or not, because the dictionary will be having the words with the right spellings, right? So it will compare that. If that is not the case, it will correct it and it will return back the word, and I'm going to append that into the review list. So now I have a column review with all the sanitization. What are the sanitization step we have done? We have spelling corrected it, we have lemmatized it, we have removed the stop words, we have removed the punctuation, we have lowercase, etc. So all these steps are done. Now I want to preserve this particular column into the another dataset. So what I'm going to do, I'm going to use df2.2csv. What this will do, it will generate another CSV file, and I'm going to rename it as updated grammar and product reviews. So I want to reuse this dataset every time when I'm going to build a machine learning or a deep learning model. Okay. I don't want to perform all these steps again and again. So I want a cleaned data set to be used, right? So that's why I'm going to save it with another format over here. Then we have a noise removal process. So what does this noise removal process will generally do? Even though we are available with a good form of sentences, we are going to apply certain cleaning techniques, right? So these particular reviews would have a tags or white spaces, etc. So for that, what I am going to do, I am going to define a function called scrub words. I am going to pass each and every word, and I am going to use a regular expression. So regular expression dot substitute any tags kind like this, any white spaces like this, or a decimal or digits like this, then white spaces with a, for spaces I can just use text dot strip. It will remove the white spaces from beginning and the back at the end of the sentence basically. So I am going to perform these three steps on the reviews column. So df review equals to df review dot apply lambda x of scrub words. So I'm going to pass each and every word to the scrub word method, and it will remove the tags, non-ASCII and the digits, and it will strip the spaces if any available. So finally I have a sentence which is free of stoppers, lemmatized, free of spaces, digits, special characters, etc. So now it is a very clean form of text or clean form of sentence which is very good to go with analysis in the further steps.